This is Adi Sharma solution. We are taking chapter 17, VSAQ, increasing and decreasing functions. Very small answer questions we are taking. What are the values of a for which fx equals to a raised x is increasing on r? See, first of all, there is a question also which is decreasing. So understand it very well. F dash x, if it is greater than 0, it is increasing. F dash x, it is less than 0, it is decreasing. So first thing we have to do is the differentiation. What will be the differentiation? It's very known to you. It is a raised x log a. Now this is increasing. That means it has to be greater than 0. This is the differentiation. This is the f dash x. So just take it one by one. Log a. Now if I say log x, x cannot be negative at all. Log negative is not defined. That is a here has to be greater than 0. First thing is clear. Now coming to the first term, which is a raised x. A raised x has to be greater than 0. A raised x greater than 0. If a is greater than 0, a raised x will be 0. How? Because see, the question may arise, this is a raised x log a. It can both be negative, it can both be positive. Then only it will be greater than 0, because minus minus is positive, plus plus is positive. Now, as we defined that log a should be defined only when a is greater than 0. And the second thing which I want to emphasize here is a raised x. What does it a raised x means? Anything with r. Means anything x which belongs to r. Alright. Now, when we have a as greater than 0, the log a will be greater than 0. I am saying this log a. I am just saying let us not be greater than 0. It is equal to 0. Log a is greater than 0. I am making it equal to 0. So that just means e raised 0 equals to a. So this is 1. A is equal to 1. But using this inequality, this is just to explain you what log means. What does it actually means? So when we say that log a is greater than, that is a should be greater than 1, right? Now log a, this is only defined when a is greater than 1, log a is greater than 0 when a is greater than 1. So this f dash x should be greater than 0 or is equal to 0, or anything which is greater than 0 is only possible when a is greater than 1. Now how we are going to do this? This is very important because this all you have to write. The only thing which you have to understand is you have to prove that f dash x is greater than 0. We have two terms, a raised x and log a. Whenever it is 0, it is only 0 greater than 0 when a is greater than 1, because we know the graph of log a. We know the value of a raised x differentiation. We know that a should be greater than 1 for increasing, a should be between 0 to 1 when it is decreasing. We are going to take those questions in a short while. So this is a very similar question to the previous one. It is saying that what are the values of a for which fx is equals to a raised x is decreasing. Previously we just saw how it is increasing. Now we have to tell why and when it is decreasing. So we got the answer a greater than 1 in the previous question. Here the same thing will do, but it is f dash x should be less than 0. That is a raised x log a should be less than 0. So when it is less than 0, that means e raised. See, first of all, log x is not defined. If you take a log, x will only take positive values. It cannot ever take the negative value. So log a, again, a has to be positive. A should be greater than 0. This we have already discussed in the previous question, because you need to be very careful and very known about this log thing. So a should be greater than 0. Now if I am saying that a raised x, if you put x as say minus 1, plus 1, because in real numbers all these values can come. But even if you put negative 1 or 1, you will get 1 by a, and a 1 by a is not negative, a is not negative, so a is not negative. So a raised x cannot be negative because 1 by a, I just explained it with example. So this less than 0, a raised x log a less than 0 is only possible when a is greater than 0 and a raised x is greater than 0. But a raised x log a, this is less than 0, log a, because a raised x will always be greater than 0, which we have just proved. That is log a has to be less than 0. It has to be negative. Okay. That is when you have two values, one has to be positive, one has to be negative. Or otherwise, then only less than 0 is possible. So log a should be less than 0, and log a is less than 0 when? I told you this is the graph of a log. We have just seen a is greater than 1, it is increasing. Between 0 and 1, if a value is there, then this is going to decrease. So a should be between 0 to 1 so that you get a raised x decreasing. A raised a greater than 1 was the previous question answer when we proved that it is increasing. So this is the point. You need to know the graph also. So this is the same thing, but the logic here is different. Previously we showed how it is increasing, now it is decreasing. Write the set of values of a for which fx equals to log base ax is increasing in its domain. Now the first thing is they haven't provided us the domain. We have to find ourselves. Whenever there is log x, a base, it doesn't matter. The thing matter is x cannot be negative. That is, anything which is above 0, x can take that value, and that is the domain. Whatever x can take, it is domain. Whatever y can get, because y is equal to fx, that is going to be your range. So x belongs to 0 to infinity. Infinity means positive value we are talking about. Okay. Next thing is increasing in its domain. So we just found in the previous question what will be the value of a for it is to be increasing. We explained it properly. Decreasing also you can define because the second question was like that. But this explanation will give you differently. See, x1 and x2 we are taking any value. x1 and x2 can be any value which is falling in this domain 0 to infinite. So there can be, see, log graphs is like this. Like the old people cane they carry while walking. This is the kind of graph which log makes. It all depends on the base a. A greater than 1 increasing, a between 0 and 1 decreasing. So we'll take two cases here. Please remember x1 and x2 has been taken such that x1 is less than x2. Case 1 will take a greater than 1. Case 2 will take a is between 0 and 1. So we have to show just the first part. I am explaining the second part just to complete. That is, the question may come, you have to show decreasing also sometime. So now x1 is less than x2. What I am trying to suggest here is, we have taken two values in 0 to infinity where x1 is lower than x2. When you take the log of both the sides, that is log a, means a is base always here in this case. Log x1 is less than log x2. When you take log, it will be less than only, you know the property of log. x1 is less than x2, so log x1 will be less than log x2 if a is greater than 1, right? Only if a is greater than 1. So fx1 is less than fx2 because this is the function only. So when we took x1 less than x2, it implies that fx1 is also less than fx2. Then x1 and x2 belongs to 0 to infinity, x1 is less than x2. So that means fx in 0 to infinite, it is increasing. We have completed the question, right? Now this is then added part. A is between 0 and 1. So x1 is less than x2. So for example, x1 is, if it is 2, x2 may be 9. Any value, right? It has to be, x1 has to be less than x2. But we are talking about a between 0 and 1. A can be, say, 0.2, it can be 0.6, like that value. If a is greater than 1, we have already taken the case 1 and we define and we explain how it's going to be increasing. But this is the critical point here. This is the point we are talking about. A between 0 and 1, a between a greater than 1. A greater than 1 increasing, you can see through the graph also. But between a falling between 0 and 1, then it is going to be decreasing. How? Let us take x1 less than x2. Now take the log. Please remember, when you take log and the value of the base is decimal, that is 0 to 1. Between 0 to 1, the inequality is going to change. That is the property of the log. I have not created it. This is the property of log. So if a is greater than 1, we don't have to worry about it. The inequalities will remain same. But soon we get a between 0 and 1, the inequality changes. So here it changed. So what we got? x1 is less than x2, but fx1 became greater than fx2. That is, x1 is less than x2 and we got fx1 which is actually greater than fx2. That is, a greater than 1, we already found out. But in this, on the right case, it is not greater than 1, but it is between 0 and 1, then only it is defined. So here it is decreasing. If you have x1 less than x2 and you found fx1 should be greater than fx2, that means it is decreasing. And the second thing is x1 is less than x2. If fx1 is less than fx2, then it is increasing. So the case 1 is the answer of this question. Case 2 is just for your understanding, because there is one more question which is coming up, which have the exact same explanation which I gave you. I hope you got the idea why it is increasing, why it is decreasing. So the answer is the only case case 1 here. How are we going to show it? This is the way you are going to write it. This is the reference. The only thing, if you understand log, what is the base E, what is the base A, what are the values you can give, what are the domain and range, and what are the properties. As I told you, this question exactly resembles the first, second and third question. So now you will say, don't solve it, we are going to solve it, because we have already gone through 3 questions like this. So we have taken 2 cases in the previous question. I told you the increasing part was the case 1, and I'm telling the decreasing part for the sake of completion, and that sake of completion is actually this answer of this question, which is question number 4. A should be between 0 and 1. In increasing it, the A or the base should be greater than 1. So this is greater than 1 for increasing, A between 0 and 1 for decreasing. Now this is the solution. There is no change at all. This question and the previous question has exactly the similar explanation, but previously we explained why it was increasing. Here we have explained why it is decreasing. Find A for which fx is equal to ax plus sin x plus A is increasing on R. So find A for which this is increasing. The first thing first is differentiation. You have to differentiate this function fx. So main thing which I tell always is the logic. The writing part I leave up to you. First thing, f dash x should be greater than 0. We are talking about real numbers, so the domain x of x, you can take any value which you know. F dash x, I'm differentiating. A is a constant, I'm writing it here, A. Differentiation of x is 1, sin x is going to be cos x. The differentiation of A is going to be 0. What do we get? A 1 plus cos x. So this has to be greater than 0. It is increasing on R. So A into 1 plus cos x should be greater than 0. Now 2 parts are here. A and 1 plus cos x. But they have not told A is what value. Let me tell you one more important fact, and it is cos x and sin x. Please remember, cos x and sin x will always find itself between -1 and 1. Why I'm telling this? Because this question can be manipulated. There is a question coming right now after this, or maybe 2 or 3 questions later, which will need this explanation. So cos x and sin x will always be less than between -1 and 1. So now I am adding 1 to both the sides. I am adding 1 to cos. So when you add 1 to both the sides, or rather when you add 1, what will happen? The left hand side will be 0. The right hand side is going to be 2. So 1 plus cos x is now between 0 and 2. Do you think 0 and 2 in between is a positive? Yes, it is. And if any negative value cannot be between 0 and 2. So 1 plus cos is positive, so A has to be positive. Or it both can be negative, but we have already proved that 1 plus cos x is between 0 and 2, which is actually positive range. So both negative is can be ignored now. So A has to be positive, that is A has to be greater than 0. But are you satisfied with this? A is greater than 0? No. When we make a number line, we go from -infinity to infinity. We are talking about A greater than 0. So anything greater than 0 till infinity is what we want. So A greater than 0 simply means A belongs to 0 to infinite. Now whatever I explained, this is written here. Now you can just write in own way. There are people who can write in different way, but the message should go to the exam. Find the values of A for which the function fx, this one, is increasing function on R. So now the domain is real number, so any number which you know is real number. Let us do it. Let us do it quickly because we have just done a question like this. We'll differentiate it, that is we'll do f dash x and find the values of A. That is, we will not stick with only one value of A, we have to find the range of value of A. F dash x, we are differentiating, sin x is cos x, minus ax is minus A, plus 4 will be 0. So this cos x minus A should be greater than 0. What does it mean? Cos x should be greater than A. I am taking A on the right hand side now. That is, A should be less than cos x. So cos x, what is the range of cos x? What is the value which cos can have? Cos can have, I told you already, it is between -1 and 1. And since A is less than cos x, what is the lowest value of cos x? It is -1, right? So A should be less than cos x. A should be less than cos x. What is the minimum value of cos x? It is negative. I'm just saying And let us understand it by the number line. This is -1, this is 0, this is 1. Now cos x is from here to here. A is less than cos x. So A is on the left hand side of -1. And what from -1, the point till we go -infinity. So A should fall between which numbers? -infinity to -1. So A should belong to -infinity to -1. This is the answer. So this is the way you are going to put it on the paper in order to explain to your examiner or write in your classwork. So if you are not able to represent what you know, there is no point or there is no fun of having any kind of knowledge if you cannot explain. Find the set of values of B for which fx equals to this one. Now the thing is, they have clearly told it is set of values of B. That means there can be various values of B. You are not only interested in a single value of B, but you're more interested in finding out the range of value of B. So fx is this one, which is you have to prove it that it is decreasing on R, and you find out the value of B. So f dash x, let us see, f dash x is what? B, x is 1, cos x is minus sin x, then plus 4 is 0 of course. So this B into 1 minus sin x should be less than 0. Now you have understood f dash x less than 0 for decreasing, f dash x greater than 0 for increasing. So this cos x, sin x, all ranges and domain should be clear to you, as I explained already in multiple times. So this B into 1 minus sin x should be less than 0 in order for us to say that f dash x is less than 0. See, x into y is less than 0 means what? One can be positive, one can be negative. Or you can reverse the thing also. 1 minus sin x. Now what is 1 minus sin x? What are the values it will fall? See, sin x is between what? -1 and 1. Sin x will always be between -1 and 1. We already know this. Now I'm taking the right part here. Sin x should be less than equal to 1. That is, this is -1 and this is going to be +1. So it has to be between 1 and -1. Alright. So sin x is less than equal to 1, but we need minus sin x because we need 1 minus sin x actually. So let us multiply both sides by -1. When you multiply negative on both the sides of the inequality, you know already that the inequality sign is going to change. So I've changed the inequality sign. Now negative minus sin x has gone greater than equal to -1. Now add both sides with 1. 1 minus sin x has gone greater than equal to 0. Oh, greater than 0 means it is positive. So it cannot be positive. I told you one can be positive, one can be negative in order to get less than 0. 1 minus sin x is greater than equal to 0. It can never be negative. So what should be there? Only B can be negative, because 1 minus sin x is positive. So B is less than 0. I am saying 2 and 3. Either if they have to be less than 0, it has to be either -2 or -3. -2 into 3 and 2 into -3 will give you less than 0. One positive, one negative. But we have already cleared that 1 minus sin x is greater than equal to 0. That means we are only left with one option, that B has to be less than 0. But we have to find out the set of values. B is less than 0. So what will be the set of values? Let me make a number line. Less than 0 means what? Anything which is below 0, but to which extent will go? Will go to -infinity. So this -infinity is the last thing we can reach. So B belongs to -infinity to 0. This is the one kind of saying that B is less than 0. Now this is the way you are going to write. And as I told you guys, everyone has different perspective. So you are going to write in a different way. It will not matter. The only thing which matters is you explain things which I explained you properly with the help of diagrams also. Now this question, we have set of values of A, again the same thing. So we'll just differentiate, we'll make it as greater than 0, and that will be increasing on R. Alright. So if you have seen from the first question, you will say, oh, I know this question, I can do it. We can just move forward. But for the sake of completion, f dash x is what? See, differentiation f dash x is what? 1, cos x is minus sin x, plus ax means plus a, b is of course 0. So 1 minus sin x plus a. What do you need? It is increasing, so it has to be greater than 0. Alright. So 1 minus sin x, we have no multiplication here. So we have to take things on the right or left. So I'm taking, keeping sin x here, and other things I'm taking on the other side. Sin x is less than 1 plus a. That is 1 plus a is greater than sin x. This is the other way of saying it. So this is minus 1 and 1. Alright. 1 plus a. 1 plus a is asking, I am greater than sin x. I am more than you. So what is the morest? Wrong word, but to prove it, what is the morest, biggest value of sin x? Which is 1. So 1 plus a has to be greater than the highest value of this sin x, which is 1. So 1 plus a should be greater than 1. When you subtract both sides with 1, or you can add -1 both the sides, a should be greater than 0. But we need to find out the set of values for a, not the single value. What does it mean? We have to start with 0, go up to wherever we want, but wherever we want will lead us to infinite, positive infinite. So a greater than 0 just means a belongs to 0 till infinite. This is your answer. Now, how are you going to write it? This is the way we are going to implement writing. If you write the diagram, it will be very good. So I hope you are able to understand this. This question we are going to take in the next discussion. Till then, thank you so much, and thank you very much.